Okay, good afternoon and welcome to our Digital Art History Lab lecture, Hunting for Paper Moldmates in Leonardo da Vinci's Codices. I'm Louisa Wood-Ruby. I'm head of research at the Frick Art Reference Library, and today it is my pleasure to have with me three very distinguished guests to discuss this incredibly interesting project that they've been working on. The first speaker will be C. Richard Johnson, who received the first PhD minor in art history granted by Stanford University, along with a PhD in electrical engineering in 1977. He is currently the Jeffrey S.M. Hedrick Senior Professor of Engineering at Cornell University, a visiting research professor in the Conservation Center of the Institute of Fine Arts at NYU, a scientific researcher of the Rijksmuseum, and senior research advisor to the Frick Art Reference Library. In the past 14 years, Professor Johnson has founded several multidisciplinary, multi-institutional projects in the new field of computational art history that are focused on the development of computer-based procedures for the matching of manufactured patterns in art supports, principally weave patterns in canvas and inner structural features in antique laid paper. The next speaker will be Bill Setheris, who received a BA in mathematics from Brandeis University and a PhD in electrical engineering from Cornell University. He is currently professor in the Department of Electrical and Computer Engineering at the University of Wisconsin in Madison, and a research scientist in the Conservation Department at the Rijksmuseum in Amsterdam. Professor Setheris has held visiting positions at the Australian National University, at the Technical Institute in Gdansk, Poland, at New York University in Abu Dhabi, at the Institute for Applied Mathematics in Ankara, Turkey, and at the NASA Ames Research Center. His research interests include signal and image processing with emphasis on the visual and the auditory, and he is author of Tuning Timbre Spectrum Scale and Rhythm and Transforms, and co-author of Counting Vermeer. His current work on image processing is focused on applications in art history and conservation, with special interest in the analysis of art supports such as canvas and paper. Margaret Holben Ellis is the Eugene Thaw Professor of Paper Conservation Emerita at the Institute of Fine Arts, New York University, where she teaches the conservation treatment of prints and drawings and technical connoisseurship for art historians. She has published and lectured on artists ranging from Raphael, Dürer, and Titian to Pollock, Samaras, Lichtenstein, and Dubuffet. Her research on artists' materials and techniques is also broad, encompassing day-glow colors, magic markers, and Crayola crayons, and most recently, pre-machine-made European papers. Welcome to our speakers. I'll turn it over now to Rick.
Thank you, Louisa. I want to start by thanking the Frick for putting this together. I've had a multi-year involvement with the Frick, and it's been one of the best collaborations within the museum that I've worked with. And I also want to give a really brief introduction to our collaboration. The three of us, Bill and I, had been working on canvas and thread counting. And I gave a talk in New York City that Peggy attended, and she came forward, and prescient as ever, she said, "Is what you're doing, couldn't it be related to looking at chain lines and laid lines in paper?" And I immediately said yes, even though I probably didn't know what I was talking about exactly at the time. And we started working. So it's been a bit over 8 years that we've collaborated, and what you're going to see is the maturing output of that effort, though we're still relatively much at the beginning, but we finally are reaching some of the goals that we had set out for ourselves. And so to give a background to those of you that may not be paper specialists, I have to tell Peggy to give me the next slide.
Hold on. There we go.
So paper is made by dipping a mold. It's a rectangular frame with wires across it that scoop in a vat of aqueous pulp, and then lifted out at the water drains through the screen. And you can see from the close-up in the bottom right-hand corner that the screen has 3 sets of wires on it. One is the most visible here, the watermark, and then the vertical lines, which are visible in the bigger picture, are called chain lines, and they're the support for the laid lines, which are the ones that are closest together and most critical in terms of the water in the aqueous pulp draining property to leave a sheet of paper. Next paper, please. Next slide, please. As shown here in this slide, those of you that have tried to make paper by hand will recall how actually difficult it is to get the thickness of the paper even across the sheet, and it does require some artisanal skill to shape the mold just right. But what happens is that where it rests on the screen, and that is its 3 parts, the watermark, the chain lines, and the laid lines, it ends up being thinner. Anybody that's held a piece of modern typewriter paper up to the light notices that there's still watermarks today that are imprinted in modern paper. These 3 features are structural features in the paper that we will use to identify sheets made on the same mold. And so that will be our primary objective, is to use these physical properties, these visible physical features, to actually identify papers that were made on the same mold, which will have interesting art historical consequences. The other fact, next slide, the other factor is how this is made, and there are 2 molds used at the same time. The figure 1 person on the left is the vat man who is dipping the mold, and in this point it looks like lifting it out, and that was what we saw from an underneath shot on the previous slide. The water drains, and as a certain amount of it is drained properly, he hands the mold over to the person who has figure 2 next to his left foot, and then takes the second mold that has been emptied previously, and this twin pair is used in rotation to make several hundred sheets of paper a day. And then the second person is actually rolling the sheet carefully off, and then the person on the far right stacks them for later pressing. You can see the press on the right-hand side. But the key for us is that there are 2 molds in a production process, in a traditional production process, up until 1800 when there were machines to make paper. And the watermarks in the 2 were made by hand to be very similar, but of course by hand, they weren't identical. Next slide, please. So the implications of the production procedure, which includes the draining of the water from the aqueous pulp, and then the screens features, and the fact that there's a pair of screens used in the production, is that a ream of paper that would be purchased by an artist will be made by at least a pair of molds. So it'll have at least 2 sets of what we call Moldmates, that is sheets of paper made on the same identical mold. There sometimes can be more, of course, but it's more typical that there will be at least 2. The idea being is, therefore, since they all came in the same ream, sheets that are identical, they have exactly the same watermarks, chain lines, and laid lines, were produced at the same time, and that same place, and it's within a narrow period of time, and a production run may last days or weeks. But the lifetime of a mold that's popular, of a popular size and therefore used frequently, can be 9 months to 2 years. So in a rather narrow time window, we can assume all the sheets we discover that have exactly these same physical features that are Moldmates have these properties that would then be useful for our historians. Next slide, please. Well, it turns out there's some problems with this idea. And the first one is this one. So I'm going to challenge you to find the watermark. It's there. Okay, this is a sheet from the Leicester Codex. And the don't try to decipher the writing. It's written backwards, right to left, and it's in Italian. This is a sheet from a Leonardo Codex, the Leicester Codex. And so there's figures and drawings on both surface sides of the sheet. You can see some vertical dark shadows with a lighter piece in the middle. Those are the evidence of the chain lines. The laid lines are at this scale not necessarily visible, except maybe in the margins. But there's, I can tell you that the watermark is on the right-hand side, as you'll see in the next slide. So we have the next slide. We have the expanded version of the right-hand side, and then it's blown up a little bit more, and you still can't really see it. So we put a red circle around the eagle, and its upside down sketch is just to its right. This means that, of course, if you can't see the features, if the human can't see the features, neither can the computer. So there's no magic involved in using the computer. We will use the computer simply to displace time-consuming processes for the user. Next slide. There's another problem. Remember the twins? Well, also when paper was made at this time, if there was a watermark that became fashionable to be used in paper, it was duplicated, not exactly copied, but the same type of watermark would be used by lots of other manufacturers. So I'll ask you this, you're the human experts. Can you tell me which of these are the same? Are any of them exactly the same? This is the question we have to ask ourselves if we're going to decide which ones are Moldmates and which ones aren't. And then if you answer that, are you absolutely certain? I mean, there's a lot of other interference in the picture, but you can see the chain lines and you can make out the laid lines in certain places. But even when you could see all the features of the watermark, it can be difficult without minutes of close looking to convince yourself which ones are the same. And then your confidence level might not be that high. Next slide. Next slide, then. So I've set the stage for what we want to do. That is, we want to identify Moldmates by matching manufactured patterns, watermarks, chain line intervals, and laid line densities. But we're going to use an approach that's a little bit different from, say, shall I call it a fad of machine learning, where you think, oh, let the computer do everything. First thing I want to point out is that experts in this field don't want the computer to typically do everything. When the computer gives it an answer, at the very least, they'd like to be able to justify it or understand why the answer was picked. And those are difficult with fully automated systems that still require enormous expertise to run and interpret. So our approach is to go in and take those tasks that are actually simply done in a few minutes by humans, but terribly difficult to program with confidence for the machine. So one of those tasks you just saw the images there crowded with other artifacts, even after we clean off the surface images, that will confuse machine learning or a computerized point trying to find similar points in very different images. But for humans, this is fairly straightforward. So our first task is to create a semi-automated piece of software that assists the user in, say, marking points that are precisely located, perhaps where two wires cross in the image itself. And that will give us a sequence of points that we can then use further. With that, we can actually pose a mathematical problem to either derive a code or an alignment. And Bill will talk about those tools in the very next section of the talk. The other task, however, is that we can't, Bill and I as engineers would be happy to give you, rather arcane graphs and, matrices of numbers and such that are pretty useless. And so what we also have to do that's a bit different in our strategy versus other strategies is to try and present or capture the results in a visually recognizable way that exploits the close-looking capabilities of our user community and leaves the decision about whether or not it's a Moldmate or not a Moldmate up to the expert who can draw on much other experience in the field in making that choice. Next slide. So here's what we want. Think of this as the wanted poster in the post office, okay? So what we're after is, this is what we headed towards as we started our collaboration years ago, a suite of digital image processing tools. And we've got to be able to handle different scales, different resolutions, because the images are coming from a wide variety of different sources, rotations, orientations, but we want to process the images to help us do the things at the below. We want to remove surface marks from transmitted light images, like the example I showed you before, because the transmitted light images will be what our main source for Leonardo. We want to compare distances between precisely locatable points in similar watermarks and the angles formed by 3 of these mark points. And that can be used to provide more precise matching of watermarks than just looking at visible features. We want to compare the patterns of chain line intervals, which is actually the first test we started with. And then we discovered we could translate what we've done with counting threads in Canvas to doing color-coded laid line density maps, which have the fantastic feature of not requiring a watermark to be able to identify a moment. And then, but the big deal we're going to focus on today, when Peggy talks about the website that we're constructing for the Leonardo results, is the ability to create, in a few minutes, precise overlay videos, which has always been the goal of the community when it comes to determining if 2 watermarks are Moldmates. And so I turn it over to Bill to show you the solutions to these problems.
Thanks, Rick, and thanks to the Frick for having us here and allowing us to talk to you about some of the work we've been doing. Rick mentioned that one of the ways that we think about talking about this problem is in terms of coding. So let me try to give you an idea of what the coding means. What it means is to be able to turn the pictures that we see into sequences of numbers by measuring things, and then compare those measurements in a precise way. It starts out, though, please change the slide. It starts out, you saw earlier an eagle from one of the Lester sheets, and it's really hard to see the details. So one of the first things we have to do is essentially clean up the images. So if you think of the upper left-hand image here, the transmitted light image, as the sum of 3 things, then our strategy is actually pretty simple. It's the sum of 3 things. What is it? Well, it's the markings on side 1, sheet 1A, the markings on the second side, sheet 1B, plus the stuff that we're interested in, which is inside. And so essentially what we're going to be doing is taking the transmitted light image and subtracting out weighted versions of the sheet 1A and 1B in order to recover the thing that we want to see, which is, in this case, a much cleaned up version of the eagle. Please go ahead. Here's another example with one of the Cardinal Hats. It happens to be tipped on its side. You saw this earlier. Again, the original is in the upper left. Notice all the markings. And somewhat bizarrely, we're trying to remove all of those pencil and pen scratchings that are on these pieces of paper in order to see more clearly the internal structure of the paper. Please change the slide. Again, if you look at the top 3, you might think there's 3 eagles there, but when you denoise, when you take away the surface images, you can see that that 3rd one isn't an eagle at all. In fact, it's a fleur-de-lis. So this really shows the power of the method in terms of allowing you to much more easily and precisely locate significant points. So we're going to be looking at, please change the slide. We're going to be looking at particular points on these pictures once we've done the enhancement. and measure certain features. Slide, please. So here's one graphical user interface that we've constructed. What you do is you load in a file. You can see I've loaded in the eagle here. And now you click in various places to create these lines. You might be able to see that they're numbered 1, 2, 3, but there's 3 lines there. And then what we're going to do is compare the lengths of those lines. Notice one of them connects 2 chain lines. One of them connects to the upper part of the eagle's wings, the lower part of the wings. And by looking at the ratios of these lines, we can get a very precise measurement of the features of this particular watermark. And then we can compare that to similar watermarks, that is to say, other eagles. Please flip the slide. Here's a flower. We've marked it with several lines. And this is what we're going to be doing through what we've done to all of the Leicester and Arendelle Codex that Peggy will be telling you about. And then essentially using these sets of numbers as a code to help us determine the equality or dissimilarity between the various images. Next slide, please. Again, here's 3 eagles. Let me show you what we do with these numbers once we get them out. Here, the 3 eagles are marked. Please, next slide. And then there's a table of numbers. Much easier to look at a graph. You can see very clearly the 3 lines that are here that are all blue are good candidates for being matches. Of course, you have to go and look at it yourself, and we'll be seeing in a second a nice tool for doing that. But the orange one down at the bottom is very clearly different. So this shows one of the asymmetries that all of these tools that we're trying to build have. And the asymmetry is that you can with a lot of confidence, we can say sheet 3 is not the same as the others. And then becomes the hard distinction of, are the ones that, in this case, those 3 blue lines that are all clustered together, are they the same or not? Next slide, please. So what we do is create an animated overlay. So here's an example with 2 cardinal hats. You notice we've marked a whole bunch of points here, 15 points, so that we can get a nice matching between them. And then what we do is we choose some options for the video. We press that button over in the upper right called Make Overlay. And if you go to the next slide, you have to wait a couple minutes to see it. And what this does is it flashes between Leicester 10 and Leicester 11. And what this overlay video allows you to do is focus your eyes on something, some point of interest, and then see how that point changes or does not change over the course of the video. Peggy will be showing you a bunch more videos later on when she tells you about why we think this is significant. But as Rick said, one of the things you want to do is leave the final decision to the people who know what they're doing. And so this is a tool that we hope will help you make a decision of, are these really the same or do they differ? Next slide, please. And you can do the same thing, kind of, with the chain lines. Here's a slight variation on that same graphical user interface, where you set that green line across. That's to help you do things in a straight line. And then you simply click on the points that are those red pluses, and then the program will automatically calculate all the relationships between the different portions of the chain lines. Next slide, please. So for example, here's 3 cardinal hats and they're marked chain lines. If we go to the next slide, we can see, there's the same thing. Okay, let's go to the next slide, thank you. And here's the data as a box of numbers. Here's a visualization in a graph. And again, you can see that there's several different groups here. There's the blue group, there's the orange group, and then there's a couple that are, not the same as any of them. And again, so what this again allows you to do, this is not a proof that they are the same. What this is it's a nice way to reject all of those that are absolutely not the same. So the blue ones are not the same as the orange ones. And we can say that with quite a bit of assurance from looking at this kind of picture. Then we need to go and make the overlay videos and really look carefully to see, are they the same? Next slide, please. And here's the pair of watermark ratios, chain line ratios. And so together you're trying to gather more and more pieces of information. The fact that both the chain lines for these orange ones separate from the blue ones and the watermarks separate from the blue ones is a good indication that it strengthens your guess that of which ones might be Moldmates to which ones. And please go to the next slide. And then a third kind of evidence is the laid lines. We're not quite as far along in the laid line density maps. Please flip to the next slide. And so here you can maybe see the laid lines. If you see my background, you can see laid lines up there, if you can zoom in. The problem with laid lines is you can't really count them manually. There's just too many of them. Eye fatigue would set in no time. So we use some signal processing tricks to essentially estimate the density of the laid lines, how many lines per centimeter or lines per inch. And then one way to look at these is to color code them. So if you flip the slide, when we color code, here is a number of pages from a French military manual in 1536. And you can see some similarities in some of these pictures. What we see here is the coding is that the red is the places where the lines are most dense. The blue is where the lines are most sparse. Flip to the next slide. And one of our collaborators, Sarah Gorski, went through this collection and located the ones that seem to look the same. You can see here they're arranged so that visually it's more appealing. The ones on the left are all sort of similar to each other, and they are different from the ones on the right. The reason we chose this nice old military manual was because, well, it had a lot of matches in it, and also because we could see the watermarks, we could see the chain lines. And so here, just by using the laid lines, we were able to essentially group them into things that might be Moldmates, and those groups were the same as the groups that we got from looking at chain lines, and the same as the groups that we got from looking at the watermarks. So that was quite encouraging. Please flip the slide. And so now I'd like to tell you, turn it over to Peggy, and she'll tell you some of the things that we've discovered about Leonardo. Thank you.
Hey, thanks a lot, Rick and Bill, and thanks to the Frick Collection for hosting us. It's really exciting to be here. Well, Rick and Bill have explained what paper Moldmates are and how they can be identified. So let's turn to the results of computational coding as applied to two notebooks by Leonardo da Vinci. The notebooks in question are the Codex Lenter, belonging to the Bill and Melinda Gates collection, and the Codex Arendelle, belonging to the British Library. The two notebooks differ in several ways, namely their dimensions, the number of folios, and how they were compiled. However, they're excellent candidates for computational coding for three reasons. The first is purely pragmatic. Photographs of the recto and verso and transmitted light photographs were already available for almost every watermark paper in both notebooks, and we are very grateful to have been granted access to these digital images, without which our research would not have been possible. Secondly, scholars have determined that portions of the Codex Arendelle and the entirety of the Codex Lenter were created during the time period of circa 1506 to 1518. Although the proposed dates for individual sections of each codex vary slightly, given the intersection of dates, it seemed reasonable to conjecture that some of their papers were contemporaneously and possibly procured in batches from a local paper purveyor. This is bolstered by the fact that the two notebooks share 39 examples of only 3 watermark types: the Cardinal's hat, the flower, and the eagle. all of which you have just seen. And finally, the papers of the first 30 pages of the Codex Arendelle, consisting of 20 full and half-size sheets, were particularly intriguing because, thanks to impressive scholarly sleuthing, it appears that Leonardo intentionally gathered them together to form a discrete notebook, which was combined with other Leonardo papers by a collector. If Moldmates are to be found among the 285 sheets that comprise the Codex today, this would be a logical place to start. So let's turn to the Codex Lenter, which scholars have suggested was written in 2 campaigns between 1506 and 1512. The notebook consists of 18 loose, full-size, untrimmed sheets of paper, which were once folded in half and stacked together. As you saw in the beginning of Rick's presentation, each sheet of the Codex Lenter is covered with dense writing on both sides, so much so that even finding the watermark is difficult, much less deciphering it and comparing it with others. Scholars have suggested that there were 2 sections to the final compilation, an inner set and an outer set, that were written at different times and intentionally put together by Leonardo. An extreme simplification of large sheets of paper folded together to form a notebook with Moldmates interspersed is seen here. So if we put our theory to work, we might imagine that if Leonardo was working with batches of paper procured at different times or from different suppliers, we would find Moldmates in both the inner and outer sets, but they would differ from one set to the other set. And not only would the Moldmates come from mold A and mold B, not only would they come from mold A, but also mold B, that alternating mold that was used by the Batman. And these are called twins, as we mentioned. As we've heard, twins have the same watermark, however, they're ever so slightly different. So in this sense, the term twin means a fraternal twin and not an identical twin. And I should note that a circumstantial accumulation of Moldmates in an artist's studio or workshop, or brought together by later collectors or custodians, is highly unlikely, if not impossible. And furthermore, the deliberate selection and arrangement of Moldmates or twins by an artist or a writer, it could not have been an intentional act, since their subtle physical differences are barely visible to the naked eye and do not impact the paper's appearance or its functional properties. All of the Lenter sheets were denoised, and then the watermarks and the chain line intervals were measured to acquire their computational codes. Comparison revealed clusters of several different sets of Moldmates and their corresponding twins. These sequences can be seen in the collation chart of the Codex Lenter, which graphically illustrates their arrangements. Note that the diagram depicts the Codex's current arrangement, which is based upon records of an early 16th century binding. There is no proof that this is the original order of the pages. In fact, a new arrangement has been proposed. There's a lot to digest in this diagram, but let me point to just a few highlights. Seen in red, 3 out of the 4 papers having eagle watermarks came from the same papermaking mold. The 4th eagle is their probable twin, formed from the alternate mold. Seen in purple, 2 out of the 3 papers having flower watermarks are Moldmates. The 3rd, again, is its probable twin. And finally, seen in green, out of 10 sheets having Cardinal Hats watermarks, 6 sheets came from one mold, and the other 4 from the second alternating or twin mold. The arrangement of the clusters of Moldmates and twins suggests 3 different but consistent paper sources. I should emphasize that this is just a suggestion. which needs to be supported by further art historical and codicological research. And in this sense, coding is a tool, much like a compass, that can point to a direction for further and closer scrutiny. Note also that sheet 5, seen as a solid black line, has a fleur-de-lis watermark. And this sheet is clearly an outlier, a singleton, as we call them. It has no context. Only when another fleur-de-lis is discovered elsewhere, and there are none in the Codex Arendelle, can we apply coding that might suggest affinities of date and geographic origin. Even more interesting, however, is the appearance of 9 Moldmates that are shared between the two notebooks, or what we call cross-codex Moldmates. A paper watermark with an eagle, seen in red, that possible twin from the group of 4, has come from the same mold as one found in the Codex Arendelle. Similarly, a paper watermark with a cardinal's hat is found in the Codex Arendelle that matches precisely 6 sheets found in the Lester, seen here in solid green. And we will see dynamic and dramatic proof of these cross-codex matches at the end of this talk in animated overlays. The occurrence of 9 eagle and cardinal's hat cross-codex Moldmates suggests a historic connection between the Codex Arendelle and the Codex Lenter. At the very least, the presence of cross-codex Moldmates points to affinities of date and place of origin of the sheet and the existence of consistent sources of paper. Turning to British Library Manuscript 263, the Codex Arendelle is comprised of 285 sheets that were assembled by a collector that range in dates from 1478 to 1518. Therefore, it appears that portions of the manuscript overlap in time with the Codex Lenter. Another important difference needs to be pointed out, and that is that the manuscript's dimensions, or its format. The Codex Arendelle is a Chordo. That is, its folios have been made from papers originally having the same dimensions as those seen here in the Codex Lenter, but which have been cut in half and then folded. Due to its Chordo format, the watermarks in the Arendelle are found in the centerfold of each sheet. A plus, because there's less obscuring writing in that area, but a minus due to damages from previous sewing holes. Also, because each sheet of the Codex Arendelle is made from half of a larger sheet, half of them will lack a watermark at all. And this is precisely what we see throughout the manuscript. Pages without a watermark are indicated in gray, are evenly distributed in this collation diagram of the first 30 pages of the Codex Arendelle. And you will recall that our focus is on this first section because scholars have determined that Leonardo separately and deliberately compiled it. As in the Codex Lenter, computational coding revealed Moldmates and their probable twins among the Cardinal's Hat watermarked sheets. The preponderance of Cardinal's Hat watermarks and the configuration of the Moldmates and their twins certainly supports the idea that the sheets have a strong affinity of date and geographic origin, i.e., they probably came from one batch of paper. The exceptions are one full sheet with a flower watermark, seen in pink, and a half sheet having a shears watermark, as seen in orange. You will recall that the Codex Arendelle consists of many, many more folios than just the sheets intentionally gathered together here. Could these unexpected insertions be Moldmates to sheets found elsewhere in the manuscript? As a matter of fact, among the other watermarks found scattered throughout the manuscript, Folio 1617, which is the one in the first 30, is indeed a moldmate with the others. But because these three moldmates do not appear in any sequence, one can only deduce that they were made from the same mold, not that they were ever packaged together in the same ream. Therefore, in terms of dating, we must surmise that the range of dates is wider. That is, the useful lifetime of that particular mold. And I should note that this particular size of paper was, as Rick mentioned, among the most popular, particularly with the growing trade of book publishing at the time. So the expected lifetime of a mold that was repeatedly scrubbed clean, continuously wet, and used 7 days a week was likely a year or so. As for the Shears watermarked papers found inserted in this first section of the 30 pages, it's a moldmate to 4 found elsewhere in the manuscript as seen here. To the right of folio 18 in the upper left, which is the one found inserted in pages 1 through 30, is another half sheet, a second half sheet. And both of these are moldmates with the 3 full sheets found below. But wait a minute. According to the Chordo format of the Codex Arendelle, if the watermark falls in the center line of each folio, that means that we should see half of the watermark in the half sheet. And that is exactly what we see. With only the 2 bottom points of the open blade visible, how can we be sure that it's really a moldmate? And the application of watermark marker isn't possible. There aren't enough points to connect. For confirmation, we can turn to 2 other manufactured patterns found in paper, the chain line intervals and the laid line densities. Regardless of whether their watermarks are fragmentary or complete, all the papers having Shears watermarks still have 6 chain lines, whose spacing across each mold is unique to that mold. And this can be graphically demonstrated in this chart of chain line comparisons. The 5 moldmates we just saw on the slide before are the closely spaced blue lines. Their chain line intervals match up precisely. A 6 Shears watermark appears as the orange line. The other manufactured pattern to be found in handmade papers is the density of the laid lines across the sheet. Like the intervals between vertical chain wires, the distribution of these very closely spaced horizontal laid lines across the screen of the papermaking mold fluctuates in a pattern that's unique to the mold. Measured in lines per inch or centimeter, laid line densities can be mapped and marked according to various colors. As seen here, the regions of low density, i.e. fewer laid lines, are colored blue, and regions of higher density are colored red. As Bill mentioned, this is a work in progress. However, I think the results in terms of mapping our 5 Shears moldmates are very promising. The laid line density maps for the 2 half sheets, seen in the upper row, are remarkably similar. Furthermore, the maps of those 2 half sheets correspond very closely to the lower half of the laid line density maps of the 3 other Shears moldmates that we were able to confirm using watermark marker. The stark difference between laid line density maps of papers made from 2 different molds can be seen here. And the one on the right is that outlier, the Shears watermark having that orange line that didn't correspond at all. Returning to our collation diagram, based solely on paper physical evidence, the insertion of these 2 sheets into a run of Cardinal Hats moldmates and probable twins, and the fact that they have moldmates elsewhere in the manuscript is noteworthy. and it suggests possible affinities between these now separated papers. Again, this shows that paper coding can act as a compass and point to future research directions. Any conclusions have to be based upon additional textual and codicological evidence. So what are the implications and conclusions? The large number of Moldmates found in the two notebooks suggests that Leonardo was using the same and or a closely dated paper source for both manuscripts. We can deduce that the Moldmates occurring in close sequence are from the same ream and therefore have a narrow period of time. Isolated Moldmates found scattered elsewhere throughout the manuscript can be dated to a broader but still quite narrow period of time, the lifetime of that particular mold. The identification of Moldmates can support existing scholarly theories of collation and dating, as well as pointing to future directions. Coding can use all three manufactured patterns found in paper, and we can identify watermark fragments. And theoretically, we can extend this technology to identify papers having no watermarks at all, such as those alternating folios in the Codex Arendelle. Singletons can be significant, but until we find others to compare with them, their presence remains a mystery. Papers can travel, molds can be sold as assets to other papermaking mills, and Leonardo was known to rearrange his notes and his observations. Singletons also exist in drawings by Leonardo, known or suspected to have been removed from his notebooks. Where would we like to go? We'd like to expand our coding capabilities to other closely related collections of papers. Candidates for coding might include disbound or scattered albums and sketchbooks, such as those by Goya, Stradenus, or Cesare de Sesto. Papers from a workshop in which papers were known to have been shared between student and master, such as Rembrandt and Boll. Drawing papers of Albrecht Dürer. Coding has already been extensively applied to Rembrandt prints with some very compelling results. Next month, we will conduct a workshop that will introduce participants to paper coding, including how to produce animated overlays. And finally, we're looking forward to making our software for watermark enhancement, watermark marker, and chainline marker part of a package produced with the help of the Getty Foundation that will be distributed under open source license. I'm very eager to get to LeoCode, which is our online working compendium. But before I switch technologies, I just would like to acknowledge the people who helped us, in particular, Andrea Clark from the British Library and Frederick Schroeder from the Bill and Melinda Gates Collection, who gave us access to all these images. Our wonderful graduate assistants and the staff at the Frick Collection, and of course, our funders. So I'm going to get out of this and I'm going to take you to LeoCode. Welcome to LeoCode. LeoCode is a working compendium of all the watermarks in the Codex Arendelle and the Codex Lenter. I should begin by stating that LeoCode was designed and created by Abigail Slawick, a graduate student here at the Conservation Center at the Institute of Fine Arts, New York University. And Abby is actually standing by in case there's any questions about the website. I'd like to take you right to the user guide. And Bill and Rick, I hope you'll interrupt with any observations that you'd like to make as I go through here. I do want to leave plenty of time for us to wander around. The user guide explains the layout of the website, and it lists the things, the items, the information that is included for every watermark found, every watermark with Moldmates. And that is a description of the watermark, and this is just a visual description of what the watermark looks like, how it differs. There's very, very subtle ways that it differs from other groups of Moldmates or singletons. We've also included the briquet comparison. And this is because briquet, the vast resource of watermarks compiled in the early 19th century, is still used as a reference for describing watermark types. And briquet numbers, which refer to specific line drawings of watermarks, are still listed in catalogs today. And so it's quite possible that someone will have a briquet number as their only guide to what they're looking for. Also listed is where this particular watermark is found in the Codex Lenter and the Codex Arendelle. It lists the potential twins. Again, potential twins can only be inferred by location in the sequence. In the visuals included for each watermark type are a line drawing, and this is a line drawing is simply for quick recognition. The line drawing cannot be used to identify Moldmates. We also include a cleaned up, enhanced, denoised image of the watermark so that users can quickly identify what it is without interference from writing or drawing. And finally, in the lower right, you see one of these animated overlays. This shows the flower from Arendelle, 1617, compared with another flower found considerably later within the same manuscript. There are many ways of using this. The Leo code, one of the easiest and probably the most popular, will be by watermark type. And before going into the familiar ones that you've already seen, the Cardinal's hat, the flower, and the eagle, I want to just very quickly go down and click on Other. The other watermark types found in the Arendelle have all been enhanced or denoised, or they're seen over transmitted light. Because as I mentioned, there's not as much obscuring writing in the Arendelle as there is in the Lester. So sometimes the transmitted light image will suffice. But here you see denoised images of the Greek cross, and you can see all the different watermarks. There are 87, if I recall. Here's a flower that I know for a fact is seen in the Forester, the Agnus Dei, mermaids. They're very unusual, the two buckets hanging from a tree trunk that's on fire. And I should also mention that the Pedretti numbers have been included. Carlo Pedretti and Carlo Vecchi, in their very important and impressive 1998 study of the Codex Arendelle, were scrupulous in listing the watermarks, as well as their briquet comparisons. And this is still used as a source, which is why it's included here. And here's the fleur-de-lis from the Lester sheet. So let's just show you how to browse a watermark. Let's say you want to see that cross codex. You want to see that cross codex. Here's Arendelle 208, 209, and the Lester sheet. And if you click, the animation is running now. But if you would like to see it a little more closely, you can click on it, and this might take a few minutes. It will expand. And you can see it in more detail. Okay, so we can go to our other cross codex Moldmate, the Eagle. Again, here you see a small version of the animated overlay. If you click on it, it can be enlarged for your scrutiny. Again, these have all been denoised of any surface marks. Going down to our shears, you will recall that this is a full sheet of the shears that shows the entire watermark itself. So this is comparing two of the full-size sheets, but all the watermarks have been denoised and are mounted. So if you'd like to look at Folio 18, which is the one from the first 30, you can click on that. And this is the animated overlay that shows a comparison between just those two tips of the open blade. But wait, there's more. There are more Moldmates in the Codex Arendelle, besides the ones that we have just seen. Bull's heads, as you know, Bull's head was a very popular watermark. There are 7 in total in the Codex Arendelle. And here you see our Moldmates. Out of those 7, there are several different kinds. You can see they're divided by groups A through E. Our 2 Moldmates are right here. Again, if you just press on it, you will see the correspondence. It's also possible to browse by codex. So if you would like to go to one of the notebooks in particular, you can also browse by watermark there. And so here's Arendelle 3435 of a hunter's horn. And you'll see, in fact, that we have a Moldmate match in our hunter's horn. Again, click on it. and you can see quite clearly. There's lots to see in this website, but I will go to the contact and credits page. Scrolling down, I would like to acknowledge the many, many people who have helped us gather all this information. And I hope that some of you in this list of acknowledgements are watching right now. We also have included imaging guidelines for anyone who would like to contribute to the website. I should mention that the website at this point is not live. It's undergoing internal review. And so here are the imaging guidelines. And finally, all credit for the website needs to go to Abigail Slawick. So with that, I'm going to stop my share and be available for any questions that anyone might have.
Hi, thank you all. That was incredible. Really exciting work that's going to help art historians and manuscript historians, et cetera, and all of us in some ways. We have a lot of questions, so I hope you're ready. The first one that came in, thank you all for the very clear and interesting presentation. I have two questions. First, you mentioned that the lifespan of well-used molds is 9 months to 2 years. What are the causes of demise, and can evidence of its age be seen in the sheets? And then second, does your process work only with images taken using transmitting light? Oh, there's a lot of questions. Let's start with the first two.
Let me take the first one because there's actually an interesting example to be seen in Codex Lenter. I think I mentioned what are the causes of demise. I mean, paper mills operated 7 days a week. If you've ever been in a handmade paper mill, and I've been fortunate to be in one, they are wet, they are dirty, it is backbreaking labor. These molds are thrown around between, passed back and forth between the vat man and the coucher, and they are wet. Excess fiber is scrubbed off of them with brushes, and they are used continuously. So there are many, many reasons why a mold would become damaged and would eventually no longer be usable. In fact, in the Lester, I think it's in the later folios, the Cardinal Hats, Group B, there's an instance where one of the chain lines has been bent. So within that group of Moldmates, we actually can see a chain line that at some point was damaged. So yes, you can definitely see it. Now you can't date it. You need too many sheets of paper to really trace that. But I know that damages do show up, particularly this. Without getting into too much detail, this family of papers had what's called a supplemental chain line, which is an unsupported chain line. It also had external chain lines, and all of these were a little more vulnerable than the others. And so this is where you can begin to see the damage as it accumulates. So Bill, why don't I let you answer the question about the images, the transmitted light images?
So we've used transmitted light images here because that's what was available. We've used beta radiographic images from a bunch of Rembrandt watermarks. And in one of the questions, someone asked about IR. Sure, it doesn't really matter the source of the images. And in fact, many of these alternative technologies are easier to use than the transmitted light because they intrinsically remove the surface features. So for instance, the soft X-ray style imaging technologies give you the writing is just invisible to that. So you get cleaner pictures right from the start and don't need to do the denoising. But the remainder of the things, the measuring and the chain lines, the laid lines, the measuring of the watermarks would all be exactly the same.
Okay, we have so many questions. I'm going to push you on because that was his first question. And it was,
can I take? There's two other questions.
Oh, if you can see them, yeah. If you can see the question.
Leah, who, excuse me, asked in what language the code is written. So it's written in Mathematica, which Wolfram has these things called computational documents, and so that's what these are. You can download a free player. It lets you use the software but not edit it. So it should be available. Our intention is certainly to make all of these programs that we showed you and several others available. They'll be released under open source license, and I don't know whether we'll put them on the LeoCode website once it becomes available, but there will certainly be links from LeoCode to whatever location they ultimately reside at.
Okay, here's a fantastic talk. Is it possible to use this approach to trace the age of a given mold? Well, that's sort of has to do with the deterioration. Paper mold wears out and starts showing defects. Does that indicate how old it is? If yes, would it be possible to come up with a chronology of sheets coming from the same mold?
Yes, Leila, hi. I believe it would, but you would need a lot of sheets. But absolutely.
Okay. Would conservation treatments affect the results due to dimensional changes in paper? Haha.
Aha.
So I get to, let me answer one.
Yeah.
So we've actually looked at that issue. This is the reason we use ratios instead of actual measurements. Because if the shrinkage actually occurs as it appears from the research I've done to be linear in the two dimensions. So in other words, the sheet shrinks by a ratio that's consistent across the sheet, but that may be a different ratio vertically and horizontally. But as long as we're taking the ratios of two distances in the old sheet that was before shrinkage and the sheet after shrinkage, the ratios between two lines drawn on them to the same spots will actually end up being the same number. The ratios are also useful if the resolutions are different. We've looked at watermarks and the X-rays Bill's mentioned at 400 dpi, 300 dpi, 600 dpi. So that's the reason we take ratios instead of pure measurements, is that it takes into account a lot of the differences in the way the sheet was made and how it might have been treated wet over time so that it did shrink and expand and shrink. And so we don't have anything formal to point to about that, but it probably could use a major experimental study. But our impression is that it doesn't have a noticeable effect. It's down in the 1% to 2% range.
Okay, here's a question from Soyen Choi. This is really interesting. With the ley line density, could two couchers have a slightly different body movement that would create a different pattern, denser or looser?
Yeah, I mean, there are all sorts of variables, and that is why the laid line density maps were only used as a backup to other methods. Bill and Rick, please join in. I don't think we're at the point where we can make conclusions based solely on laid line maps. ley line density maps. However,
a lot of that has to do with the availability of images in which the laid lines are clear enough to be essentially counted. If you simply take a snapshot with your iPhone or something, chances are it's not going to be at a high enough resolution that you can see the lines. In the Lester Codex, they were all photographed at just about 300 dots per inch, and that was very marginal for getting the laid line maps. The Arendelle was photographed at about 600, and those were much better in terms of getting the laid line maps. In one sense, the higher the resolution, the better.
Okay.
I'm more optimistic about the laid lines being unique patterns. So I think if I don't know enough to say, but my sense is that the impression of the laid lines is set very quickly when the mold is being taken, and so and the people I've observed that make it do not vibrate the vibrations they give to smooth out the thickness are very slight. And in fact, it's just a little bit of vibration to make the flow happen. And they have a very limited amount of time to do this. So I'm more optimistic that the laid lines ultimately, if we can figure out how to quantify their similarities, will be a major advance, because about 2/3 of the watermarks, 2/3 of papers that have been cut down for prints and such have no watermark at all. So at this point, without the watermarks and I saw one of the questions asking, how different are they? Well, they're all handmade. Okay, so every one of them is unique, and we've looked at literally hundreds of Rembrandt prints. We didn't have that many of the Leonardos yet. We hope to have more. And it's amazing how close the matches are once we go to the video. It's astounding. So but again, only a third of them can be identified that way.
Someone asked, has your work been applied to Michelangelo's drawings?
No.
no.
We need images.
Yeah, that's the problem.
This is part of, Peggy said this, but I guess, I know Bill is nodding his head yes. I mean, that's what we're hoping for. We think this can be applied to an enormous range. Somebody asked about music scores. There's actually a fairly well-known book from late last century where he looked at Mozart scores, but that's clearly another possibility if they're of the right age, pre-1800. Manuscripts, sketchbooks, legal documents, historical documents. It's not necessarily just limited to art objects. I mean, there's been big studies in Europe on accumulating watermark databases, but until you can do something like this semi-automated overlay that we have, it's very, very difficult to search them and very difficult to compare them. And so that's where we're headed, is that we'd like to provide tools to handle really big projects. So yes, we'd like to do every watermark in Leonardo. And we'd like to do Michelangelo, Dürer, Goya, I don't know, all the biggies, printmakers and such. So not necessarily us. I mean, we'd like to provide everybody with the tools for them to do it themselves. Is what our main objective is.
Yeah. These two questions can probably sort of be answered together. Someone's asking, it's nice that you can identify the papers from the same mold, but is it really relevant to the order of Leonardo's writing? Isn't it possible that some could come and he had supply of paper produced by different molds, et cetera, et cetera? And the next question is, or comment, really, it seems to answer the first one. The person was struck by the observation that some of the more interesting problems are best tackled by a combination of computers and humans. seems like that one answered the first one. Would you all agree?
Yeah, I would like, we're not Leonardo scholars.
Right.
This is just a tool that can be used to support scholarly research. So yes, absolutely. It won't indicate that if Leonardo decided to change the order of his sheets or happened to travel to France with a batch of paper. Again, this is just a tool.
I liken it to a detective, and you don't know whether it's the lipstick smear on the glass on the mantelpiece, or the cigarette butt in the ashtray, or the footprint outside the window in the garden that's going to be the piece that's going to unlock the mystery. I mean, there's just so much other stuff that has to be involved. But what we hope we're providing are tools that didn't exist 10 years ago. And so I think that all of a sudden this should enlarge the ability to draw conclusions from the physical properties of the paper that didn't exist previously.
Okie doke. Does the system take into account the question of mold or felt side? Which side have these pictures been taken from?
Peggy, go.
It doesn't matter.
Yeah.
If you look at a sheet of paper, it can be this way, this way, this way, or this way. So there's 4 different orientations. So the program takes that into account. So it doesn't really matter if you're looking at this side or this side. Now, of course, where it does matter is other kind of analysis, but not in this particular problem.
Is it related to the forensic study of fingerprints? Well, sort of. It's the same kind of thing in a way. But.
No, I would say not really. I mean, the big difference with what we're looking at, the watermarks are curvilinear, but the chain lines and ley lines are linear, and you don't have features like that in fingerprints. The patterns that we see are very repetitive. I mean, fingerprints are, the variability is even greater than it is among watermarks. So we haven't used any of the same tools. I've contacted people that are doing fingerprint analysis as well, but the way it's done is quite different.
Okay. This is a question about the codex. Is the model of the codex in hand the same as other codexes that do exist at this time? Well, there were 2 codexes. We know that what is in the royal palace is not the same as others. So is each book made exactly the same? Or did Leonardo change them each time they were put together?
Well, that's a question for Leonardo scholars. But,
we would love to know the answer to those questions.
Yeah, I can tell you that the ones that I have seen and studied have all been very different.
Yeah. Can the use of matching chain lines, sorry, that one changed, matching papers indicate the date of Leonardo's writing on the papers?
No, it only indicates the date of the paper. So the paper could have sat in the stationer's store for a number of years. We would not know that.
He could have had a pile in his studio in the back that he forgot about and brought it out 10 years later. Yeah. What type of university degree is required to learn these processes?
It depends on what level you want to use them. We will try to make it usable. If you can handle Photoshop, then you can actually use all the tools that we're developing. So no university degree of any technical sort is needed. Bill and I have also stressed the use of mathematics that's no more advanced than, say, sophomore level engineering. So we're not trying to go for the fanciest possible. We're trying to go for algorithms, at least the mathematical formulation that's after the marking, at a level that's so well known and so well studied that we can expect it to be very robust, so that there's not too many surprises in how it behaves. You do not need to know advanced signal processing, for instance, to make the few choices that we give you with the buttons in the GUI. This is all a very deliberate approach. In the future, once this community gets used to these tools and trusts them, I expect that those constraints will weaken and that there will be more advanced tools, hopefully, to be able, I mean, here's my example. If we all had to know thermodynamics to be able to drive a car, we'd all be walking. So, and if you're going to, design an engine, you have to know thermo. But we really are quite attentive to trying to make these things as broadly useful as possible. And the enormous amount of that credit goes to Bill, because he's our programming genius, wizard, whatever you want to call it. So, but that's deliberate.
2 questions about Leo code. Can the public access it? I think you said it. Well, anyway. And does it have a password?
No, Leo code is not available yet.
And will it?
We hope soon, yes.
Okay.
But we don't have an date.
Here's what type of images are required for this type of work? RAW, JPEG, etc.
So, I mean, it depends a little bit on which. If you're dealing with watermarks, then essentially any imaging technology that lets you see things clearly is good enough. Chain lines tend to be fairly easy to see, even in pretty crowded pieces of paper. It's really the laid lines that are going to require sort of high resolution images. And by high resolution, it's something like 600 dots per inch is a kind of number that you would want.
And we prefer that the images you give us at that resolution are not compressed, TIFFs rather than JPEGs.
Yeah, it's like the difference. If you know about like what camera raw is, that would be preferable to TIFFs. TIFFs would be very, very much preferable to JPEGs, because JPEGs have a compression technique, and maybe this is more than you want to know, but often the laid lines are 8 or 10 pixels apart, and so you're that's in a 300 or 500 DPI picture. They're often 3 or 10 pixels apart. JPEG quantizes things in 8-bit square little pieces and then pastes them all together. And so JPEG introduces artifacts that are almost at exactly the same scale that we're looking for laid lines. So please don't use JPEG.
Martin Kemp says he's raised his hand. So Martin, would you like to appear, I guess, is what yeah. Let's see. I'm not sure how to make him appear.
Stand by. I can get him on for you.
Okay.
I no longer see him in the list, so maybe we just move on while I look.
Okie doke. There's just so many questions that we didn't get to that one, and I guess he had to go. Let's see. For dating reasons, I think we answered that. It's good to hear that the software will be distributed under an open source license. I've been thinking about using it to research duplicates owned by 16th century collectors of prints and on print series, which sequence was mixed by collectors in albums. What are the preferred properties, dimensions, DPI? I think you just said some of that. What? Sorry.
But let me add, though,
Okay.
in terms of that question, it may be a little while before we actually post these things because we prefer to have the software in a very solid state. So if you were willing to sort of be a kind of help us test things type person, then contact one of us and then they'll contact me and we'll get you the software now, basically.
Okay, and you could contact the three of you through the Frick Dolls email. You can email the Frick Doll programs.
Okay.
We're also in
If you know our names, you can
Google them and find them. They're all
Yeah.
we're also writing user guides for all the pieces of software as well.
Lots of thanks. How expensive would paper have been during this period?
I can't give you an exact figure, but I can tell you that it wasn't cheap.
Not as expensive as it is now. If you were to try to buy one of these Leonardo pages.
Yeah.
Paper was a very, very, a precious commodity, which is one reason why both sides of the sheet are covered with writing. I think it's generally agreed that paper was not cheap, but don't forget also that this was a time of booming industry in the book publishing trade. So the demand was very high. But at the same time, the paper making mills were expanding as well. So, not really an answer. I'm sorry.
Well, the assumption in the Rembrandt community is that paper was expensive enough that when he was ready to do prints of plates he just etched, he would buy enough paper, but not an excess of paper. So he would go through the paper. He bought about 6 packages a year, or made 6 purchases a year. So it was expensive enough that you didn't stock it up for years in advance.
J. Dillon, Rare Books and Manuscripts, have these watermarks never been radiographed? Is denoising better than radiography?
No, radiography is better. In general, but it's more expensive, harder to do.
Sure.
And the availability of images drives a lot of what we're doing.
Exactly.
You can't put the radiography device in a suitcase and carry it with you on an airplane. Okay, but you could if you had a photographic system set up to take, transmitted light and surface images that were standardized to fit with our software. In fact, we have a colleague, Paul Messier at Yale, who we're encouraging and is in the process of trying to develop a portable system of that type. So the idea is radiographs would be great, but we can't expect everyone to have access. So that's the other reason we're talking to a great extent about the possibility of doing all these same things with transmitted light and surface images, because it's more likely that devices to do that will become standard in the future.
Okie doke. Several of the watermarks appear to be Italian, but not all. Have you looked into possible location of watermarks paper makers? Sorry. Thanks.
Hi, Kim. That I'm leaving that up to the paper people. Yes, the watermarks do appear to be Italian, but we need someone with much deeper knowledge about paper making in terms of the watermarks than I possess. So.
Okie doke. How do repairs made to a watermark interfere with the comparison of molds? How easily can one identify that it was a repair?
Well, you still have your chain line intervals and to go on. So if the watermark needed repair, and very often they did, they got damaged through this scrubbing. because the fibers accumulate on these molds, and they have to be cleaned off. So very often a little wire will get bent. In fact, on the LeoCode website, you can see a Cardinal's hat that has a loose wire. But at the same time, you might think it is a mold mate to another, but those chain lines will still back up any confirmation, as well as the laid line. We hope the laid line maps, which of course are in progress.
In the study of printmaking, and I'm only really aware of a lot of the work being done for Rembrandt, the assumption is that if you have a line that's damaged and it's visibly different, that the likelihood of that appearing in the same ream with paper that before it was damaged is so low that the decision is made to call that a separate watermark. So, because they're trying to date things to within a year. So if it's damaged and you happen to buy paper, even though the chain line patterns may match from the same mold, the other issue that's related is watermark replacement. So you could have the mold, the laid lines and chain lines last longer than the watermark. Okay, because the watermark has features that are easily damaged. And so I know that watermarks are sometimes replaced. These are the things that drive people crazy. But on the other hand, what we've discovered is that these are a tiny fraction of what we're looking at. I mean, I'd say less than 10% of the images have these kinds of visible deformations. Maybe it's a little higher, but it's somewhere relatively low. So I guess I would like to say from the engineering perspective, the tools we're developing are meant to solve the vast majority of identifications. We know there's going to be weird ones waiting out there to be found, okay? And at some point, new knowledge and maybe more advanced tools will be required. But the way we do it in engineering is, okay, we can do 90%. That's great, we're done. The 10%, our message to you is hire a consultant. So,
Probably the kind of damage that's most common is when the paper's folded, like this one right there. Because what can happen, of course, is then the two sides are a little bit like this, which means that when you measure, say, chain lines going across, you're going to have a slightly different.
Yeah.
And, so you have to just be aware of that. I mean, I don't know that there's a fix for it that's perfect, but I mean, you need to be, when you see damage, you need to think about how it impacts any possible identification.
And then in the case that Bill's mentioning, the most likely thing we would do would be to break it into two halves.
For example, and then see if the two halves match.
Yeah.
Have your findings had any significant impact yet on the ordering of either of the codices? Are there any restorative practices that preclude or detract from the process? Catherine Marquette in Rome.
Selected scholars are pursuing further research based upon the directions that have been suggested by the coding, but I'm afraid I don't know the results of their research yet. In terms of restoration, I'm probably going to start. It takes a lot to change the orientation of chain lines and laid lines once they've been formed into a sheet of paper. I probably shouldn't say that as a paper conservator, but not really. As Rick pointed out, we did wash and flatten a number of papers, trying to figure out if the washing process, we surface cleaned them as well. We washed them, we dried them, and flattened them. And there wasn't any significant interference in the ratios of the measurements, the distances.
Right, so the paper could have shrunk, but it was still the ratio of the distance between this and that chain line was the same as the ratio, even if the distance was larger, correct?
Correct.
Yes. And the other thing too is it's impossible to discount the Martian coming through the window and doing something to the piece of paper. And so, these things, these kinds of things are not absolutely conclusive in every possible scenario. And at this point, because we can't, it's hard for us to imagine all the possible scenarios. As I said, I guess in my previous remark, we're going after the 85 to 95% of cases that don't seem to have any of the problems that haunt experts.
Are there serious efforts underway to create some sort of master watermark database, and by whom?
There's databases you can find pretty quickly online. The European Union has had more major projects than we've had in the United States, for instance. So if you're looking at Western papers, there are huge databases. And then there are websites that you can find without too much trouble that actually list the set of databases that you can go to. So it's possible to see on. I'd start with the International Paper Historians website, which has a listing of lots of websites and books. And some of those websites themselves are also collections, like the Bernstein Project website. And they have hundreds of thousands of watermarks.
Richard Berman says, thanks for an extremely informative and interesting presentation. Looks forward to the website and wants to know why one would need to use Photoshop.
Oh, you don't have to. I just mentioned Photoshop as the level of programming complexity you might need to be able to handle some of the instructions we use, click and drag and these kinds of things. But no, we avoid using a commercialized product that requires you to buy it entirely. And so all of the things you need to run our software are described in the user guide for our software. So you don't need Photoshop.
You've been discussing examination of manuscript pages. How would the method need to change, or would it, to study printed pages?
I'm assuming they mean printed as in books rather than prints as in etchings. Prints as in etchings, we have also a body of work that's been devoted to them, right, the three of us. So there's plenty of places to look for that. Books, again, you have to be careful. We're talking about historic laid paper. So books that have been printed after 1800 would be on what's called wove paper, and the techniques are completely different. The appearance of the inner structural properties is completely different. So our work wouldn't apply to that. It's again a question of obtaining the image that clearly shows the inner structural features. After that, it's kind of the same. How you interpret the way it was collected for a book, there you could assume that at least the book manuscripts that we've looked at that are unbound and available to us through the study collection at NYU, they might come. Well, the book that Bill mentioned, those were blank pages inserted for note-taking by the students in these books. And we found 2 pairs of twins. So there were 4 dominant watermarks and such in that book. So the big advantage for books for us is that you're guaranteed to find lots of Moldmates, okay? Because they're going to be buying a ream and making the books, printing from that, and then the next ream. So it's an area that we haven't looked at only because we haven't been afforded the images we need to do our study.
How would you suggest imaging watermarks in paper that's applied to a wooden substrate? Someone already answered reflectance transform imaging
Yeah.
is
Yeah.
one method, but I don't know if it can be used with this software.
Or conceivably IR.
Yeah, but you've got to be able to maybe, for the reflectance, you might have to be able to lift the sheet and put something
No,
underneath
the
it.
reflectance transformation imaging would just image the topography. If this
Yeah.
thing is
Oh, okay, yeah,
ironed
right.
down, if this thing is really ironed down to wood, you may not have much topography left.
Yeah, you'll have the wood photography.
But I don't know. It depends. I'm sorry.
Good endocrinological.
Yeah, I mean, RTI is, you have a bunch of images, and then you can essentially reconstruct an approximation to the three-dimensional structure of the surface from that collection of images. So we don't, I mean, the software as we use it now only deals with one image at a time. So if it was useful, you could simply take the nicest looking of the various reflected images and use that.
I guess I would add to that, Bill's being maybe a little bit modest, but Bill and I were involved in a separate project a few years ago on photographic paper. And those were identified with texture. And so that was one example where the texture was everything. And some very straightforward raking light images turned out to be suitable to decoding, if you will, the texture. And contact Paul Messier at Yale. He's building a giant repository using that software, and Bill is still an advisor to that effort. So it's moving in a completely different direction for the basic tool that's used. If you're looking at surface topology, what we have now, as Bill pointed out, is not designed for that.
Damon, sorry.
Oh, no, I was going to say, the other thing about RTI is that it tends to give you really interesting pictures of very small areas.
Yeah.
And, one of the things that we're looking at here is the breadth of the page. When you're talking chain lines, the more chain lines you have, the more accurate any results are going to be. And same with blade lines. So being able to image the whole page sort of at once is a real boon for transmitted light, for instance.
I was going to say Damon Crockett's going to present on that tool. He works with Paul at Yale on March 11th in part 4 of our Computer Technological Revolutions in Art History Symposium that, Rick, you were part of in the first symposium day in the fall. Anyway, if anybody's
along with Park, who's also listening in today.
Yes, I saw Park.
Yeah.
Nadine Orenstein says hello to all of you, and great to see how your work is progressing. Danielle Silverman asks 2 questions. I don't really understand the first one. Storage process to prevent deterioration. I'm not sure if they mean the mold or she means the mold or the paper. And the other question is, do the ancient and old-fashioned manual processes create better results rather than the computerized tools such as Photoshop?
Nothing will ever be close looking and connoisseurship.
With a microscope.
I don't know. I'm not quite sure what the question is, but I'm happy to consider it.
Well, my reaction would be is we're not trying to supplant or displace any of the traditional techniques. What we're hoping to do is enlarge the range of forensics that can be used by experts, rather than say, this is the only one you need to use. We're emphasizing the fact that this is just another tool in your toolkit, and bring all your knowledge to bear anytime you use any of the tools.
There have been lots of praise for for all of you.
We want to hear all of those.
But there's so many questions. We have just a few more, but I just wanted to mention so that you know that there's been lots of praise. How about drawings and prints that are mounted on another laid paper? Any suggestions?
Yeah, that was Tina's question.
Of course.
Difficult question.
No, it's an easy question.
No, but I'll tell you this, because I had some ideas too. Go. I mean, if you're a chain line, it depends what it's mounted to. If you can if we can differentiate between the laden chain lines of the primary support and those, assuming it's a laid paper, of the secondary support, theoretically, someone like Bill could separate out.
So, for example, suppose paper was oriented, the other was oriented this way, so that the chain lines were sort of. Well, then you'd at least stand a chance.
Yeah.
But I mean, if they're located like this, and all the laid lines are over top of each other, and all the chain lines are, you can't tell which one's which.
Yeah. We got asked the same question when we started doing canvas. What about a canvas it's mounted on another one? And they used a radio opaque glue to attach it. And when we first started doing thread counting, these were the questions everybody would sneak to us to see if our stuff really worked. No, I mean, yes, we understand that there are situations like this. I mean, prints that have actually been glued to cardboard, or drawings that have been mounted that way, you're not going to get a transmitted light image. There are mounting problems in obtaining the types of images you would need to see internal structural properties in the paper.
One person in the chat put, she was just saying it was really useful for her. She works on a nonprofit educational organization, manuscriptevidence.org. I can, WPME, Watermarks and the History of Paper. So she was very happy. That was Mildred Budney. And the last question, unless someone has another one, as you know, moldmates or twins, as Alan Stevenson says, can be very much different. Sometimes you understand that there are twins only thanks to their distribution in the document. Is this taken into account? Or maybe don't moldmates and twins correspond to the same concept? I'm doubting now.
It can be very confusing. I understand that entirely. As I said, only when you see these sequences can you start to assume that you're dealing with alternating molds. Once those sequences are broken, and this is just my opinion, I know there are some paper historians who will disagree with this. I personally don't think you can establish the mold A and mold B. Now, once that sequence is interrupted, because that mold, let's say mold B, continues to be used. They are not always used together, alternating. They don't live together for their entire lives. They're separated at some point. Let's say one gets damaged. The other one is continued to be used. These are valuable materials. So, I think that once that sequence is disrupted, it would be very difficult to establish the twin, the mold A and the mold B. Now, I know that there are paper historians who have far deeper knowledge of paper than I do, and perhaps they will disagree.
But then I'll give a slightly different answer for prints. So with prints, you are interested in papers that were actually used at the same time. So if you have a batch that has twins in it, and you assume that they're consuming it at that time, then twins are seen as coming from the same batch of paper. Mm-hmm. So they don't distinguish between the two if they're trying to establish a date of creation of the artwork. So, because both of them were manufactured at the same time. So they don't care which one it is, though they will identify it in a catalog, and they do that by finding the same, that pair on this, used for the same plate. Okay, and so the example I'm most familiar with is Eric Hinterden's catalog of Rembrandt watermarks. And so there, if you mistake a print because it's so similar to the other mold, it's not a big flaw because it won't affect the dating that you're really after. So again, a lot of the answers to these things do depend on how this forensic evidence that we're identifying will be used in the subsequent analysis, and it will change depending on the type of object, book, manuscripts, prints, but it'll also change based on any information you have about the practice of the artist. If you know that they always buy paper from the same shop, okay, we don't tend to have evidence like that until 2 centuries later, but all of that will affect. I mean, if you have a workshop with lots of assistants, and the assistants may have all been drawing on the same stack of paper for doing drawings during their educational time, then it becomes a big scramble. Or if you have artists that, like Rembrandt and Jan Levens, that shared a studio when they were first learning to print, you might find watermarks used by both of them. So it's, again, I reemphasize the fact that it's one piece of forensic evidence. Knowledge of the particular artist and their particular intent, studio practice, etc., has to be taken into account. But this is undeniably physical evidence that can add to the, if you will, assumptions about studio practice given little documentation.
Okie doke. So are there any more questions? This is your last moment, everybody. Panelists, do you have any last remarks or sort of follow-ups to questions or thoughts you didn't cover? I think you've been really brave to be here for all this time and be peppered with lots of questions and answer them so intelligently and kindly.
I guess we've said this before, but I'd like to emphasize once again our willingness to work with experts that have challenges in dealing with their paper, where the understanding the Moldmates and watermarks and so on and so forth, if they find that interesting, we're more than happy to engage in collaborative projects, because doing so will strengthen our understanding of how our tools are used, and more importantly, will likely lead us to develop new tools that could be useful in situations that at this point we're not familiar with. And so we would encourage you to contact any of the three of us with these ideas that you have. And thank you again to the Frick. This was a great, fun experience.
Thank you. This says, wait, one thing. Contact Martin Kemp, says John Barton.
Okay.
I guess he had to go.
Peggy will do that, I'm sure.
Does that mean, I'm sorry, does that mean we should contact Martin Kemp?
I think that's this.
What it sounds like.
But the person was saying John Barton. Yeah.
Okay.
He had a good question, and he was very interested.
Oh, there's questions being added right now.
Watch out.
Oh my gosh, 5 more questions have popped up. Oh, what exciting work. Thank you again. Thank you. You mentioned a program involving Damon Crockett on 11 months. It's called Technical Revolutions and Art History, and it's about a number of different kinds of computational art history projects that are being developed. There's actually going to be 10 presentations on March 11th. It's at the Frick again. You can sign up on our website, Technological, and Damon Crockett will be in the first half, so from 11 to 12 on March 11th. And then let's see, congratulations.
The rest are all thank yous.
Yeah, okay. So So with that, thank you so much for preparing this for us, for our audience, for taking the time, and it presents so beautifully, so clearly. It's very, very wonderful of you. Here's the link, to register for March 11th in the chat. Thank you, Sarah, who helped organize this. We had one staff member who really organized this, Ellen Prokop, who has moved on to other fields of endeavor. And she's here today. So thank you, Ellen, for getting this all organized and working with everybody. And we just took over for you. And I think that's all, unless anybody has anything else to say. Okay, so goodbye, everybody. Take care.